In today's video, we are going to create 2048 game in Kivy. By the end of this video, we will have this game which will work with touch on the mobiles and arrow keys on the PC, so keep watching. Hi there, welcome to Saral Gyan. This is the third video of the Kivy series in which we are learning to create GUI app in Python using Kivy. If you haven't yet watched the previous videos, you can watch them to learn the basics. If you are new to this channel, please subscribe and hit the bell icon for future notifications. So let's start coding. Open the terminal and I'll create a new directory called 2048 and then cd into it. Now I will be creating and activating a virtual environment running Python 3.7 because Kivy is compatible up to Python 3.7 only. If you want to know more about virtual environment, watch our previous video on it. So here Python 3 minus m when dot. And now to activate it. And now we will install Kivy. Create a main file. And here we will do from kivy.app import app, and then we will create our game class and we will say class game app. And for now we will be just passing it. Firstly, we will be creating a board for our game, and that would be a 4x4 square having 16 tiles. And to create our board widget, we will import from kivy.uix.widget import widget. Then we will create a class which will inherit from widget, and inside this we will say define and then finally we will be saying self.resize. We are yet to create this function. What the init method is doing, it resizes the board according to the screen at the time of the initiation. Now we will create the resize function, and for that we will be doing define resize, and it will take two arguments, self and args. And first of all we will do self.canvas.before.clear. Here we are using canvas.before because it is executed first when a widget is being rendered, and then we will render the board. And to do that we will be using a 9-patch image with the name of board.png, which I have already saved in my working directory, and you can get it from the GitHub link which I will provide in the description below. Since we want to give it rounded edge, we will be using border image, and to use that we will be doing from kivy.graphics import border image, and then in this method with self.canvas.before we will say border image position will be equal to self dot position, size will be equal to self dot size, and the source would be the image board.png. And here we will be doing on is resize, and on size is equal to resize. This will resize the board on repositioning. For example, when the screen size is changed or you change it from portrait to landscape. Now we will create a layout file, and following the name convention we will have to name it game.kv. We will be doing subl game.kv. Here we will be using the universal padding of 20, and to do that we will say set padding 20. So we'll create a float layout and place the board inside it, and we'll give it an ID of board. And since we want our board to be a square, so we'll be doing size would be minimum of root dot width comma root dot height minus 2 times of padding, and we'll multiply it by 2. So here we are using the minimum of height or the width and then subtracting 2 times paddings from it, and just to give it length and breadth we are multiplying it with 2. Then we will say size underscore hint is none, and then position underscore hint is we want to center it, so we'll be doing center underscore x is 0.5, and center underscore y is also 0.5, and then root dot center. This will align the board in the center of the screen, and then we will move back to our main.py file, and in our game app class we will say define on underscore start and self, and then we will say board is equal to self dot root dot ids dot board, and then we'll run the function board dot resize, and I think we should move it under this class, and then we will be making two import. The first one would be from kivy dot co dot window import window, and then from kivy dot util import get color from hex. Here we have imported window at the very top because we will be using it at different places, and then if name is equal to main window dot clear color would be equal to, and we will be giving it a white color FAF 8EF, and then we will say game app, and if you save it and run it, so we have got a syntax error here. We move back to Kivy file and it should be a dictionary, so I'll change it to a dictionary and then save it and go back to a main file, and if you run it, so now we have got a rounded board, and if you resize our window the size of the board also changes, so it works well. Now we will add cells to our board, and for that we'll move back to our code, and since we will be needing 16 cells we will be creating a generator function where we'll say define all cells, and what it will do, it will for x in range 4, for y in range 4, it will yield x and y, and then we will set the overall spacing equal to 15 here. So each of our cell would be a square, and each row would have 4 cells and it would have 5 spacing in between. So we will move back to our code, and inside our resize function we will declare the size self cell core size, and this would be equal to 0.25 times self dot width minus 5 times spacing, and since we need it 2 times we'll multiply it 2, and here we will create a new function called cell position which will take 3 variables self board x and board y. Here the board x and board y are the board coordinates, and it will return self dot x plus spacing plus board x multiply by self dot cell underscore size 0 plus spacing and self dot plus spacing plus board underscore y multiplied by self dot cell underscore size 1 plus spacing and save it. So what we are doing here is we are taking the x and y coordinate of the board itself, then we are adding the spacing to it, and thereafter we are using board x and board y, which would be generated by our all cell generator and would be 0 0 for the first cell and so on, and multiplying it with the cell size and the spacing, and then adding all this will give us the exact xy position of each cell. And now moving back to a resize cell, here we will say color star get color from hex, and we will give it a color of CCC 0B4, and then we will be doing 4 underscore x and underscore y in all cells, border image, and its position would be equal to self dot cell position of board underscore x board underscore y, and the size would be equal to self dot cell underscore size, and then we'll be passing the image, which is again a 9 patch image, cell dot png. In graphics we will be importing colors also, and now run it. So now here we have got our board with 16 cells in it. So visually all our cells are empty, but to apply our game logic, these cells need to be empty programmatically too, and for that we will move back to our code, and here inside board we will say b is equal to none, and then we'll create a new function called reset, and we will set self dot b is equal to, then we'll be using nested list comprehension, and none for I in range 4 for j in range 4, and here instead of resize function we'll be using the reset function. So if you run it, we still get the board. Next up we will start creating our tiles, and for that in our main.py file we will need two necessary imports, and that would be from kivy.properties import list property and numeric property, and here we will create a new class called tile which will inherit from widget, and this we will say the font size of the tile would be equal to numeric property, and that would be 24, and then number on the tile would be again numeric property, and by default the number would be 2, and then color would be a list property, and then we default would be get color from hex, and we'll be giving it a default color 4DA, and here it should be the rounded brackets instead of the square ones, and then the color of the number again would be a list property, and then it will get color from hex 776E65. Since we would be using different background color for the different number tiles, up here we will be creating a list of the colors, and I have copied it from my snippets. So this would be holding 11 colors for 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024 and 2048, and then we will create a new dictionary of tile colors. This would be 2 raised to the power I color for I in enumerate colors, and for I and color in enumerate colors, and we'll start from 1. For I is equal to 1, 2 would be this color, and so on. And here, instead of hard coding the color, we will be doing tile colors 2. And now here we will create a init function, and it will take self and a default number of 2 and quarks as argument. And first of all, we will be doing super tile dot self dot init quarks, and then we'll be doing self dot font underscore size. We'll be giving it the half the size of the self, and then self dot number would be equal to number. And then to update the color with the number on the tile, we will be doing self dot update underscore colors, and here we will be creating our update color function. So it would be doing self dot color will be get color from hex tile colors, and then self dot number. So this will set the color of the tile according to its number, and then if self dot number is greater than 4, we will be doing self dot number underscore color would be get color from hex f9 f6 f2. So what we are doing here is, if the number is more than 4, then the tile is darker in shade, so we'll making the color of the number white here. Let me show it in the example. So here the background is light, so it is grayish in color, but as you move, so here the background becomes orange, so the color of the number becomes white. Moving back, here also we'll create a resize method which will take 3 arguments, self, position and size, and then we'll be saying self dot position would be equal to position, self dot size would be equal to size, and then self dot font underscore size would be equal to 0.5 into self dot width. And now to display the tiles, here down in the resize function we will be doing if not self dot b return, and then for board underscore x board underscore y in all cells, tile would be equal to self dot b board underscore x and board underscore y. And if there is a tile, we want to tile dot resize, and the position of the tile would be equal to self dot cell position of board underscore x and board underscore y, and the size would be equal to self dot cell underscore size. And inside our game.kv we'll create a new widget called tile, and here it will be a canvas, and inside the canvas we will be giving a color of RGB self dot color, and then we will be adding a border image to it. Border image would be equal to self dot position, and size would be equal to self dot size, and source would be equal to cell dot png. and then its labels position would be root dot position, and size would be equal to root dot size, and bold would be equal to true, and color would be equal to root dot number underscore color, and font size would be equal to root dot font size, and text would be equal to string of root dot number. Moving back to main.py file, we will be adding two number tiles to our board randomly, and to do that, inside our board we will create a new method called underscore tile, and it will take two arguments, self and args, and then we will be saying empty underscore cells would be x comma y for x comma y in all cells if self dot b x y is none. So here we are checking whether the cell is empty, and if self dot b dot xy is none, then the cell is empty, and then we will be doing x comma y is equal to random dot choice of empty underscore cells, and we will also have to import random. So up here let's random tile is equal to tile, and its position would be equal to self dot cell underscore position x comma y, and size would be equal to self dot cell underscore size, and then at x and y we'll be inserting the new tile, and then we'll be adding this widget. And finally, in a reset method, we will be doing self dot new underscore tile and self dot new underscore tile. Now save it and run it. So we have got an error of with base tile colors too. Okay, so we don't have to include these here. So save it and run it. So now we have got two tiles at random position, but we still can't move it, and we will use keyboard keys to move them in on our PC. So let's save it. So let's move back to our code, and to bind the keys, so here with window we will be importing the keyboard also, and then we will be copying pasting, and then we will be creating the key vectors. So if we press the up key, it will move y by 1. If we press the right key, it will move x by 1. If we move the down key, it will move the y by -1, and similarly if we press the left key, it will move the x by -1. And now to listen to our keyboard talks, in our board class define on underscore key underscore down, and we will say self dot window dot key and args, and then we'll say if key in key underscore vectors self dot move key vectors key. Here we will be doing window dot bind on key down dot on key down. This won't work as for now because we haven't yet created our board.move method, but before creating that we need to create two move functions which will check the valid cell and the valid moves. So inside our board class we will be creating two methods. The first one would be valid underscore cells, and this will be taking self board x and board y as arguments, and it will return board x is greater than 0, greater than or equal to 0, board y is greater than and equal to 0, and similarly, and here it should be less than and equal to 3, and it should be less than and equal to 3. So basically it will be checking the coordinates of board x and board y, and since we have 4 by 4 cells, so it would be between 0 and 3 for both, and if it is between 0 and 3 it will return true, and otherwise it will return false. And then we will see whether we can move our cells. So we will say define can move and a tile can only move if the cell is the valid and if the cell is empty. So here we will say return self dot valid cell. So let's remove the plural from both of the cases. Here we will be saying board underscore x, board underscore y. So first of all it will check whether the cell is valid, and then it will check whether the cell is empty. So if the cell is empty, then B board X and B board Y would be none. And since we can move our cells up and down and left and right, and we can't move from the very top to the very bottom using the up arrow, so we will move back to our all cells, and here we'll change it a bit and we will say flip underscore X is equal to false and flip underscore y is equal to false, and here we will be doing reversed range for if flip x, else range 4, and similarly we'll copy this and paste it here, and instead of x we will say y and save it. And now we'll create the move function. So we'll say define move. So here it will be taking two direction x and direction y as its arguments, and we'll say for board underscore x comma board underscore y in all cells, and direction x should be greater than 0 and direction y should also be greater than 0. So we will be doing tile would be equal to self dot b board x and board y, and if there is no tile then we will continue, and then we'll say xy is equal to board x and board y, and then while self dot can move to x plus direction of x and y plus direction of y, self dot b x and y would be equal to none. So we will be making the previous cell empty, and then we will be doing x plus is equal to direction of x and y plus is equal to direction of y, and then at the new x and y position we'll be adding the tile. And if there is already a tile there, so if x is equal to board x and y is equal to board y, then we'll keep on continuing and do nothing, and then to show the animation we will doing anim is equal to animation position is equal to self dot self underscore position xy, duration is equal to 25, and the transition. And now we have to import the animation. So here we will be doing from Kivy dot animation import animation. And now I will explain you the move method. First of all, we are looping through all cells for which x and y are greater than 0, and then declaring the tile equal to board x and board y, and if there is no tile we won't take any action, so we have set continue here. And then we are setting board underscore x and board underscore y equal to x and y, and if we can move in the direction x and direction y, then we declare previous coordinate that xy is equal to none, and then move the x and then add direction x and direction y to board x, and then we create a tile at the new location. If there is already a tile there, then we don't do anything, and then we have animated it. So if we save it and run it, so here we have to say in reverse range for range. And before saving it, I have made an error. I need to copy this line here instead of the name main method, and if you save it and run it, we have a board and it can move. Here the tiles can move, but you can notice two things. The first one is the tiles cannot merge, and the second one is the tiles start to move in a new direction before the first movement is complete. So we will take care of both of these things, and first of all we will create a merge function. So let's close it, and in our code, in our board class, we will create a new function called can underscore merge. It will take four arguments: self, board underscore x, board underscore y, and the number. And two tiles can merge only if they are of same number, and to check that we will be doing return. First of all, we will be checking whether the cell is valid, and then we will be checking that the cell is not empty, and finally we will be checking whether the two numbers are same. So here under this, if self.can merge, and it will take x plus direction of x and y plus direction of y, and the tile dot number self dot p x y is equal to none. So if two tiles can merge, we will be making the previous tile none, and then we will be adding the direction of the movement to both axes. And then we will be removing the old tile, self dot remove widget self dot p x y, and then we will be adding the new tile, and finally we'll be doing tile dot number and multiplying it with 2 because it will double. And then we will update the color of the tile dot update underscore colors. So now after merging or otherwise, we need to add one new tile after each move, and we will also take care of the bug which moves the tile before the first move is completed. And to do that, in our board class, here we will be saying moving is equal to false, and in a move method at the very top we will say if self dot moving return, and then below here after the animation we will be doing if not self dot moving nm dot on complete is equal to self dot new tile, and then we'll set the moving to true. And in our new tile method we'll be setting self dot moving to false. And one more thing, these should be indented to the left and it should be in the same block as this, so we will move it to left and then save it. And if we run it, so see, now we can merge our tiles and the bug is no more there. The new movement is started only after the previous movement is completed. But most of the game has an end condition. It's either the victory or the loss. In this case, the game will be over if it is deadlock, and the player will win if he makes 2048. So we will implement the same in our code, making the win condition is quite easy. Here we'll say if tile dot number is equal to 2048, we will you win the game. And then we will create a method for deadlock, and here we will say define is deadlocked, and it will just take self as an argument. And first of all, if there is an empty cell, then it is not deadlocked, so we will be doing for x comma y in all cells if self dot be x y is none, return false. And then if a tile can merge with the another tile, then also it is not deadlocked, so we will be doing number is equal to self dot bx y dot number, and if self dot can merge x plus 1 comma y comma number, or self dot can underscore merge x comma y plus 1 comma number, then also we will return false, otherwise we will be returning true. And to check this deadlock method, we will go into our new tile method. So we have to keep this deadlock above the new tile. So let's cut it and paste it here. And above here, we will be doing if length of empty underscore cells is 1 and self dot is deadlocked, then print game over, board is deadlocked. Here you must note that as of now we are just printing the game over and win condition only in the console. You can add the functionality of showing it on the board. Let me know in the comment section how you did it. And finally, to make it cross platform, we will be adding the touch capability to it, and for that we will be importing vector. So above here we will be saying from key dot vector imp vector, and then under this we will be creating a new function define on touch up self dot touch, and v will be equal to vector touch dot position minus vector touch dot oppose, and then if v dot length is less than 20, we will be returning true or false. And then if absolute value of v dot x is greater than absolute value of v dot y, then we will be doing v dot y is equal to 0, else v dot x is equal to 0, and then self dot move v dot normalize. So let me explain what we have done in this code. So first of all, we check the length, and It eliminates very short gesture. If the travel distance is very short, it probably would be a click or a tap and not a swipe. Then if absolute v dot x is greater than absolute v dot y, condition sets the shorter component of the vector to 0. The remaining component does designate the direction. It means if you move your finger, it will be moving both in x and y direction. So whichever is the longer direction, we records the move in that direction only. And finally we normalize the factor and feed it to board.move method. So now let's save it and run it, and now we will try to reach one of the game over condition. So now it seems to be in that low condition, and if we go back to our console, it says game over, board is deadlocked. So now we have built a simple functional game, but there are few other features which you might like to add, like showing scores and high scores on the screen itself, adding new tile with number 4 instead of 2, displaying won and game over condition on the board itself, and much more. I would like to hear in the comment section how have you enhanced this simple game. And this is it for this video. If you have enjoyed it, hit the like button and share it with someone who needs it. And in our next video we will learn to create Flappy Bird game clone, and to be notified about it, subscribe to our channel and hit the bell icon. Thanks for watching. Bye bye for now.